Questions starting up right about now. Which of the following is not an example of a redox reaction? You've got the first one, CuO plus H2 giving you Cu plus H2O. The deal with this is कि कब होगा कब नहीं होगा, यहाँ पे not लिखा है. Write down the oxidation states. यहाँ पे copper का 2 plus था और plus 2 and यहाँ पे 0 है. So this is clearly is a redox reaction, hence not the answer. What's the answer to this one? बहुत simple सा question है. This one again is going from what? Plus 2 to 0. यहाँ पे 2K. Oh yeah, 2K, not the resolution. It's plus 2, 0 to 1. So that means that this must be the answer, and it is. This is a double displacement reaction. तो पहला सवाल थोड़ा ज़्यादा ही आसान हो गया, but this is it. This is a double displacement reaction. How can I be confident? Well, you can just check. यहाँ पे barium is at a plus 2 state. Here also it's at plus 2. Hydrogen is plus 1. Hydrogen also is plus 1. Chloride is at negative 1, negative 1, and you know the rest. S is at plus 6. Oxygen is minus 2. If this is going a little quick for you, please take some time and check out my older sessions and all the theory. We're just doing these practice sessions closer to the exam because the JEE is in a couple of months. I know NEET mein thoda time hai, but I thought I'm going to do practice sessions right now. So the answer to this one according to me is this one right here. Yeah, 4. It's straightforward. Question number 2. The more positive the value of E naught, the greater is the tendency of the species to get reduced. Okay, we'll digest that question, that first statement. Using the standard electrode potential of redox couples given over here, इसमें से कौन सा which of the following is the strongest oxidizing agent, which means that it likes getting reduced. I like writing that down right on the, we'll look at what the question is asking for, but likes getting reduced, right? मैं इसको लिखना चाहता हूँ ताकि you have this in your mind. If it's something the good oxidizing agent, it itself gets reduced, right? They are two sides of the same coin. ठीक है, ये पहला statement लिखा गया. We'll do this question. The question is not a big deal. What does this mean? Greater is the tendency of species get reduced. It makes sense, right? Because E naught is defined as reduction, right? Since we define E naught as reduction in most of our basic studies, that means कि अगर positive value हुई, then the tendency to get reduced is great, yeah, to get reduced. That's what यहाँ पे ऊपर लिखा हुआ. Okay, cool. Now looking at these, you may be like, hey, look at this. Iodine is the only like a halogen over here. So maybe this is the answer. Don't do things like that. Look at these numbers. Numbers यहाँ दिए हुए हैं. दिया भी हुआ है. Literally सवाल में दिया कि what's the highest positive value. So the answer clearly is this right here, plus 0.8 volts, right? This is it. This should be the answer. Yeah, very, very straightforward. Question number 3. E naught values of some redox couples are given below. On the basis of these values, choose the correct option. मजेदार चीज है. यहाँ पे you've got all positive values interestingly. So all E naught values are positive. Just noticing a trend here. Doesn't mean anything as such. Okay. Options में Cu will reduce, Cu will reduce, Cu will reduce. If Cu is reducing something, मतलब Cu is getting oxidized. Since Cu is getting oxidized, मतलब कि आप लोग आंसर दो. I'm just in the spirit of solving the question, I'm solving it. If you have the answer, please put it out on the chat. Go for it. Yeah, do that. These questions have to be done this quickly. Yeah, copper oxidize हो रहा है, मतलब कि ये होगा एनोड पे. अगर copper एनोड पे होगा, तो E naught, for E naught to be positive, this is the process to solve this question. E naught is positive, and what is E naught defined as? It is E naught reduction of the cathode minus E naught reduction of the anode, right? So what we are saying is that, okay, something minus copper needs to be positive, right? That's where we're getting at. What do you think? Is this all right? देखो मैंने बहुत चीज़ें यहाँ पे लिखी हैं, but this looks like ये थोड़ा लंबा solution है, मतलब इतने सोचना बहुत time लगाना पड़ रहा है. But this question is significantly easier than all of this. You don't have to do any of this. And look at the right hand side as well. See, a lot of times you take a hammer to a question and you try and solve it, but it serves your purpose. I know exam में anxiety होती है, exam में बहुत हम लोग जल्दी चीज़ें करना चाहते हैं, but spend a little bit more time reading a question. Sometimes your life will be easier. This is one of those questions. अगर आप इसको ध्यान से पढ़ेंगे, look at the right hand side of this. Cu will reduce, ठीक है. What will reduce? Br minus. अब देखो Br minus से और कहाँ जाएगा? Where is it going to go to? Reduce it to what? This is it. इससे और lower oxidation state bromine का है नहीं, right? Okay. You know that bromide or say bromine has oxidation states of -1, 0, then I think it has +3, +5, +7. I'm not sure if it has a +1 state or not. I think it has a +1 as well. We'll look it up on JD. I think it has a +1 state as well. खैर, इससे नेगेटिव और जा ही नहीं सकता है, तो रिड्यूस क्या करेगा? सिमिलरली सिल्वर इज एट 0, इट्स ऑलरेडी एट 0, और कहाँ जाएगा? इट कैनॉट गो एनी लोअर. Iodide also -1 cannot go lower. Hence the answer must be 4. This is a 15-second question that you should be picking. Now this is the quick way of doing it. If you want to spend some time and recheck this, अरे ये doubt हो रहा है ये सही है कि नहीं है, let's see, okay, which means that I have to make this value negative. Cu plus to Cu इसको negative करना है. क्यों? क्योंकि Cu reduce कर रहा है तो मतलब Cu खुद oxidize होगा. Hence उसका value ही हो जाएगी. There's one way to do it. Other way is to do it the cathode anode way, which you are already comfortable with. ठीक है, इसको negative कर दिया. And plus what? Plus this value 1.9 as is. This gives me a positive E naught. But if I do any of these other things, अगर मैं इनमें से कोई भी और चीज करता हूं, इनमें से मतलब कि look at options 1, 2 and 3. Yeah, I have negative 0.34 for the copper couple. Top right corner पे लिख रहा हूं if you're that's not evident right away. इसका ये है, see this is getting, sorry उसका उल्टा है ना, this is getting oxidized. Okay, so Cu2 plus. For this the E naught value is negative 34.34. Now बाकी सबका even from this number way all of these values will reduce. मतलब कहाँ करेगा ये? This doesn't make sense, right? Br minus को reduce करेगा to what? I don't have any, there's no math value, there are no values for me to plug in as well. So this is where you're going to get stuck saying hey, how do I do it with the math? What does bromide get reduced to? And then you realize there's nothing for bromide to get reduced to. So the answer is straightforward, it's easy. Please don't get stuck in this sort of a question. Yeah, this is one of those questions to trip you up, but if you look at it from a bird's eye point of view, ये काफी straightforward question भी है. I spent a lot of time on this question. You don't have to, right? This is a 15-second question, but I thought it's good to analyze what's happening over here. Question number 4. Using the standard electrode potential, find out the pair between which redox reaction is not feasible. This is one of those things, right? Not feasible. Okay, ठीक है. Okay, not feasible. ठीक है. So you will notice that on the left hand side, 3 of these have the oxidized, the higher oxidation state, right? Let me write that down. It has a higher oxidation state, so to speak. Fe3 plus, Ag plus and Fe3 plus, because Fe3 plus goes to Fe2 plus. Matlab, okay, in this case, all of these are at the cathode in the first case, yeah? ये सब cathode पे हैं. And then these 3 have to be on the anode. Okay, cool. Anode matlab they must get oxidized. Okay, matlab we have to subtract this, right? Is इन तीनों का हमको sign बदलना है. We have to, what do you call it? Reverse the reactions. Yeah, reverse all of these reactions, which is this reaction, copper वाला जो मैंने अभी highlight किया है, और iodide वाला reaction. इन दोनों को हमको reverse करना है. अगर reverse करेंगे तो sign negative हो जाएगा. Are you following what I'm saying? Right? I understand that this is a revision sort of a course where I'm, just solving questions, but you have to know the theory inside out to be able to do this. Yeah. What I'm doing quickly over here is just कि E naught value यहाँ पे होनी चाहिए overall will be just simply same चीज़ है, nothing new. Cathode minus anode. ठीक है. और अगर हम लोग couple इन दोनों के बीच में कर रहे हैं, then all of these are at the cathode because ये reduce हो रहे हैं. So Fe3 plus is going to be 0.77, Ag plus is going to be 0.8, Fe3 plus again is going to be 0.77. I'm going slow on this one, but the answer again, the way to solve this question, I'll tell you very quickly how to do that right away. Yeah, वो मैं बाद में बताऊंगा. But पहले यहाँ पे हो क्या रहा है? If this you're very new to this, then I'm just doing that. Minus anode क्या है? Iodide का anode will be just 0.54. This looks like it's a positive value, so no tension there. Iodide and दूसरा copper था, right? दूसरा दोनों में copper था, तो 0.34, no negative, 0.34. Cool, all of these are positive. So the answer must be 4. This is the long way of doing it. What's the short way of doing this? The short way of doing this is look at this यार. एक जगह Ag plus है, एक जगह copper है, एक यहाँ पे Ag और Fe3 plus है. You notice that this trend is opposite of this, which means कि I would have to put this one at the anode and this at the cathode. The moment I do that, यहाँ पे कुछ अजीब लग रहा है मुझे, and my first 15 seconds will be spent on just reading this question and then figuring out कि अच्छा इन दोनों में फर्क है. This was a difference. So I'm going to now just as a hunch इसको पहले calculate कर लेंगे. ठीक है, just as a hunch, and that works out really well actually. So you do just 0.77 minus 0.8, and this is a negative value. This is negative 0.03, and hence that's not going to work. Yeah, this reaction is not feasible. So exemplar के questions are slightly more tricky than the regular NCERT ones, as you can see, but they're also not that difficult. Yeah, अगर आप उसमें 15-20 सेकंड लगाओगे, you'll be good. Yeah, was this okay? Any questions? Any doubts so far? I want to mention something important over here, right? A little bit of a theory inside, and I'm aligning this with question 4 itself. हम लोग पढ़ते हैं थियोरी में हम लोग पढ़ते हैं कि E naught is given to be 0 for a H plus H couple, H plus slash H couple. ये जो आप टेक्स्ट देख रहे हैं आपके स्क्रीन पे, this is from page 168 from the 5th edition of J.D. Lee, and I thought this is important, interesting thing to note. But hydrogen हम लोग उसको arbitrarily 0 तो वैल्यू दे देते हैं, but that's actually a reducing agent. I mean, if you've studied metallurgy, I know metallurgy अभी syllabus में नहीं है आपके, but if you've studied it, if you generally have an idea, hydrogen is used as a reducing agent, yeah? So what gives, what is that value जहाँ पे things are equally oxidizing or equally reducing? Because hydrogen is not it, yeah? Interestingly, if you go and ask ChatGPT, hey, what is the value at which things are equally reducing and equally oxidizing, it'll give you the answer as 0. I'm like, no, it's not. You know, I bugged it quite a bit actually. Then this is ChatGPT 4.0. I was like, no, that doesn't make sense. It's a reducing agent. And it just kept going in a loop. Because I read this in J.D. Lee and I wanted to just see what the bot says. So, what they're saying is that from experience, around this 0.8 volts, which is actually the silver couple, yeah, it's neither an oxidizing agent nor is it a reducing agent. Okay? And they've given a lot of theory around it, right? They're saying points इसके आसपास ये है, 1 के आसपास ये होता है. तो J.D. Lee is a very interesting book, but I wouldn't recommend reading it for a test per se. मजे के लिए पढ़ो, and it'll help you in JEE Advanced for sure, because it has random things like this that you will either know or you will not know. There's no way, it's very hard to find information on the internet, but it's there in the book, so it's a very beautiful book.